Alright, so what I'm trying to do for you here is derive some of the kinematic equations that you were familiar with from the previous year using calculus. So what I'm setting out right now to do is derive V of t equals V initial plus AT. Okay, so we know if you are accelerating with a constant rate, let's just say you're in free fall, then you're gaining a certain amount of speed each second, and it's the same amount of speed each second that you're gaining. So we know A versus T should be a straight line. Technically speaking, if you are in free fall and G is negative, it would actually be down here in the negative quadrant. Nonetheless, the area in this graph here, if you accelerated from 0 seconds right in here to some value t, then the area in here has meaning. And the meaning of that is delta v. That's a change in velocity from, for this case, 0 seconds to some value of time t. So if you're using calculus, you would say A equals delta V over delta T. But that's really an average. But in the case that you're accelerating at the same rate all the time, then the average is the same thing. It's like saying, if you got a 70 on a test score, and you got a 70, all you ever got was 70s on your test scores, then the average is obviously a 70. So when you're talking about the average of a constant, it's just whatever you get on every test score. So in this example, even though it's an average acceleration here that we're representing, we're talking about constant acceleration motion like in free fall, which means you gain the same amount of speed each second. So if we were looking at this in terms of calculus, you'd write A. Let me actually back up for a second. Actually, I won't. You write A equals the limit as delta t goes to 0 of delta v over delta t. This is if you want the exact acceleration at a very moment in time, but in this application, the acceleration doesn't change in different time values. It's the same. Nonetheless, when you apply the limit here, you get A equals dv dt. Okay? So this is really a statement that says if you know V of t, V is a function of time here, and if you take the derivative of V of t with respect to time, then you'll get acceleration at that very moment in time. You could either do one of two things. One is this, by integrating this, you can get an equation that gives you the exact velocity as a function of time, or another way of doing it is getting a change in velocity over some time interval. But nonetheless, let's just go through with this. So we'd say, okay, if I separate my variables out, I get dv equals a dt. But remember, this is constant if we're applying this to free fall. Acceleration doesn't change. It's just a constant amount that you gain in speed per second as you fall. Then we would have to integrate this. We'd have to integrate both sides. So you end up with v equals, we can pull out our a because it's constant, and integrate dt. And what we end up with is v equals, at plus a constant. This is the constant of integration here, see, that you guys learned about in calculus. But the constant of integration always corresponds to the value at 0. So for us, at 0 means at 0 seconds. Well, we already know v of 0 at 0 seconds is really your initial velocity. And this over here this is a function of time here. So we can say, okay, v of 0, we apply this, say v of 0 equals a times 0 plus c, and all you end up with is v of 0 equals c. But we already knew that v of 0 equals v initial over here. So c equals your initial velocity. So when you plug that in, you get v. We're really plugging this into this equation right here. We end up with v of t equals this constant here, right here, we now know is v initial plus at. And that's the equation for velocity as a function of time that we already used quite a bit in the previous year, just even in the honors class. The next step I'm going to show is how to get a position formula from this using the same kind of rule of integration. So if you look on the same spot on its learning underneath this, you should see part 2, which is to show you how to get the position formula from this.